Hi everyone, thank you for joining me today, and we're going to start with grade 9 math. Today's Sunday, so that's why we're speaking on math for grade 9 students. The topic is real number system, and this is session 1.1. So that's what this is, okay? So the real number system. So the first thing we're going to look at is natural numbers. What are they? They're numbers starting from 1, 2, 3, 4, and so on. You keep counting. So if you think about natural numbers, you're just going to be counting in a natural way. And that would be something you would do from your kid growing up. You would just count from 1, 2, 3, and so on. Whole numbers, however, the only difference between natural numbers and whole numbers is that whole numbers start at 0. So 0 is included in whole numbers. So any number from 0 up to infinity number, then that would be whole numbers. Okay, so 0, 1, 2, 3. Integers are numbers that include negatives. So we have -3, -2, -1, 0, 1, 2, 3. So as you can see, as you go to the right, your negative numbers decrease in the absolute value. So when you say absolute value, the absolute value of -3 is 3, but it's negative. And therefore, -3 is smaller than -2, which is why it's on the left side of the 0, and it's further away from the 0. So you start at -3, then you go -2, -1, then you go 0, 1, 2, 3. And as you continue up, it goes infinity. So those are called integers. What are rational numbers? Rational numbers are any number that can be expressed as a fraction or a decimal. So quarter is the same as 0.025. Okay? A third is the same as 0.33. And a half is the same as 0.05. And how do you get a half, a third, and a quarter? It's the same as taking, for example, a quarter. In order to find that out, it's the same as taking a quarter and you're going to divide that 4 into 1, right? And if you're trying to divide that into 1, you have to put a decimal place here because you cannot, it's not possible to put it into 1, but you're going to use the 0 as a space saver. So now you can say, so 4 into 0, you can't. So 4 times 0 is 0. Okay, and then you're gonna subtract 0, that's 1.0. That's a long division. 4 into 10 goes 2 times, right? 4 times 2 is 8, and you're gonna put it over this side. Okay, and that's 4 times 0.2. You're gonna subtract, and then now you're gonna be left with 0.2. And then now you're going to have an imaginary 0. You're going to bring that down to 0.20. And then you're going to get 4 into 0.20 is 5. So that's how you get 0.25 or 0.25. So this is why a quarter is equal to 0.025. Okay? And then irrational numbers, they don't have any pattern. They can be expressed as decimals over here or as square root numbers. So 0.1357421, if you continue with that, you'll find that it's gonna not have a pattern. So it could be infinity random numbers coming after the 1. where you see that 1 there. And that's basically what the different real number system entail. So now we're going to go into an overall view of what we just talked about. So we're going to show you how they're related, and we're going to show you an easy way to look at it in the form of a Venn diagram. So in the form of a Venn diagram, we're going to put it in this form, okay? So we have 2 types of numbers, as you saw just now. And the good thing about watching this, you can pause the video and you can read the information, write it down in your books, and so on. So in this box, we're going to call it rational numbers. And I will explain this in a second. And then we have 2 circles inside. Okay, so overall, all numbers are rational numbers. That's why this is as a heading. And then inside here we have what we call integers. And next we have what we call whole numbers. And then inside the small circle we have natural numbers. So let's explain what that means. All natural numbers are whole numbers. And the reason why all natural numbers are whole numbers is because natural numbers start from 1, 2, 3, 4, 5, 6, 7 going up. But because whole numbers start at 0, all natural numbers are whole numbers, but all whole numbers are not natural numbers. Let's move up to the next level. Whole numbers are also integers, because remember, integers have negative numbers, right? They start from -3 and so on. And obviously not -3 is the first starting point. You can go from -infinity, right? A -1,000,000 all the way, count down to 0 to the right. And then you get to 0, then +1, 2, 3, and so on. So all whole numbers are integers. And all integers are rational numbers. And the reason why they're rational numbers, because every number can be expressed as a fraction. I should have said that before. So even a 4, the fraction of a 4 is equal to 4/1. That's a fraction. So even though it's a whole number, it can be expressed as a fraction, which is a rational number, right? And any number outside of that in my list will be called irrational numbers. And that would be the best way to look at the number system, which is called real number system. So irrational numbers are numbers that are outside of this group over here. So this group, they're not related to this. So these two are not related at all. Because again, these numbers are, by the example I made, so not negative, but square root of 22. And as you relate that to 0.1357421. So let's go into a little quiz. So we're going to talk about different kinds of numbers. And then you're going to determine whether they're rational or irrational. And we're going to say why they are rational or irrational. So going back to what we talked about, 0.25. Is it a rational or irrational number? Remember what irrational means. Irrational is it continues and there's no pattern. So a rational number, it represents decimals that have a final number at the end. So if it's 0.25, it must be rational because there's nothing here. There's nothing here. And the reason is because it stops. It doesn't continue. Okay? Number 2. 0.6010347. If this was irrational and it stops, that means this would be the opposite. So this is irrational. And the reason why it's irrational is because it continues. And it continues to infinity. As another thing, there's no pattern. So 2 things, it continues and there's no pattern. And the reason why we need to differentiate that is because if you had something like 0.2525, then that would not be a irrational number. So that would not be a rational number. It would be a rational number, and the reason is because it has a pattern. So if it has a pattern, like in this case, it is not irrational. So a rational number must stop at some point and have a pattern. So you can actually stop at 0.25 because no matter how far you go, if you continue, just have 2525 continue. So you can always stop at the first 2 or the first 4, whichever one you choose. So that's why an irrational number must continue with no pattern. And I think you know the answer for this one. What do you think? If it's 4 or 5 decimal places, it must be rational, right? Because it will be the opposite of what we said in number 2. Number 2 has no pattern. In this case, it continues, but guess what? It has a pattern. So it has a pattern. And the pattern is 1 1 1 1 1 1. It continues, doesn't stop. Number 4, it's 4 0 1 8 5 7 3. What do you think? Is it rational or irrational? If you say irrational, you're right. And why? It's because it has no pattern and does not stop. It continues, right? So this one is the same. Number 5. -7.5. So let's figure out what this is. This is a fraction, right? And we said fractions are integers, and integers would likely, well, it's not an integer, sorry, because integers are whole numbers, but rational numbers are numbers that can be written as a fraction. So if it's a fraction, that means it must be a rational number, because that's what we said first. Rational number can be written as a fraction. These kinds of numbers can't be written as a fraction because it continues and there's no pattern. So any fraction must be a rational number. No matter what it looks like, it must be a rational number. And you can also write it as, and I'm going to show you. So 7.5, that's a negative. So how you turn it into a mixed number is the same as 2 times 7. So you do 2 times 7, which is equal to 14. And then you add 1, so 14 plus 1, and I'll show you what that means, equal 15. So that would be, the 15 will now be the numerator. And then you keep your denominator. And it's a negative. So that will be your fraction. And this is called a mixed fraction. And this is called an improper fraction. So I just converted my mixed fraction to an improper fraction. And a proper fraction would be what we showed you earlier. Proper fraction would be just a half. Something like that. So anything that shows the denominator smaller, or the denominator bigger than the numerator, will be called a regular or proper fraction. I hope you can see that. Let me just write it here. So a proper fraction is like a half or a quarter or even 3/4, because the denominator is bigger than the numerator. And these are called proper fractions. And again, this fraction, negative 15 over 2, that's called an improper fraction. I just put IP. Improper and F fraction. And then the one that has a whole number and then a fraction beside it is called a mixed fraction. Mixed fraction. So when I teach, I actually go into other topics while I'm talking, because I find that it helps, especially when you keep repeating the information. If you don't repeat the information, then it feels like you will forget. So I have something that you could try on your own. So 0.1013 to 5.5, 3, 7.09000134, 0.666, negative 10.001, 0.001, 0.1222357. 0.12112. 210.01357.8. So you can give your point here. You can select either rational or irrational. So you can put R or I. It depends on what you think it is in this column. And then over here, you can say why it's rational or irrational. And if you want to share that with me, you can share it in the chat, and then I can respond to it. And then I'll give you I'll tell you whether you're right or not. Okay. So we can go into something else quickly. And we're still on 1.1. That's a unit. So we're going to do a little bit of test. So when you're adding numbers, it's important to know how to add decimals. So we're going to add these numbers. 0.1 plus 0.01 plus 0.001. How do you put that in the formation that you need to put it in? So it would have to be like this. 0.1, 0.01, 0.001. So you have nothing up here and nothing up here. So you just pretend that they're zeros. So you just pretend this is a 0, this is a 0, and this is a 0. Just as a place to fill the space. So you add this way, 1, add that way, 1, add that way, 1. So the answer is, so you can answer, is this rational or irrational? I just put IRR. Is it rational or irrational? If you say rational, then you're correct. What about this one? Okay, so let's go to another one. Point 333 plus 0.666 plus 0.999. So we're just going to put them here. 0.333, 0.666, and 0.999. So you're just adding 9 and 6, 15. That's 18. Carry the 1. 9 and 6, 15. 18. That will be 19. And same thing. 19. Carry the 1. That's it. So is this, so this says 998. This is a tricky one. Is it rational or irrational? It has to be rational as well. If you say rational, then you're right. And the reason is because it stops. There's nothing here. So it has to be rational. And that is basically 1.1. So next time we're going to be doing 1.2, and that will be on so 1.2 next time, you can prepare for that, is going to be adding and subtracting. Integers. And that's interesting because it's interesting how you can figure that out with just a simple strategy. So that's what we're going to be doing next time. I hope this has helped you to understand the foundational information here on the real number system. That's very key. If you understand that, you can move to the next level. And each time when you move to the next level, it's easier for you to understand what you're doing. I find that sometimes students, they don't understand the first step and then they can't move to the second step. If you have any questions, you can leave it in the chat. And if you need help, let me know and you can send it in the chat as well. Thank you so much and enjoy doing grade 9 math.